Hi class, how are you today? Oh, how am I? It varies. The learning target for today is to be able to create and understand a bots and Whisker plot. For your scale, you're 3 if you can create and understand a bots and Whisker plot. 2, you can create or understand a bots and Whisker plot. 1, you can calculate some of the 5-number summary. 0, you cannot calculate any of the 5-number summary. Let's get started. Section 3.3, Percentiles and Bots and Whisker plots. Focus points. Interpret the meaning of percentile stores, compute the median, quartiles, and 5-number summary from raw data, make a Bots and Whisker plot, interpret the results, describe how a Bots and Whisker plot indicates spread of data about the median. We've seen measures of central tendency and spread for a set of data. The arithmetic mean, x bar, and the standard deviation, s, will be very useful in later work. However, because they each utilize every data value, they can be heavily influenced by one or two extreme values. In cases where our data distributions are heavily skewed or even bimodal, we often get a better summary of the distribution by utilizing relative position of data rather than exact values. So what we're saying here is that if you have a bunch of values that are between, say, 0 and 10, and then you have one that's, say, 5,000, that's going to change your mean and your deviation, and it'll change your data a lot. However, if you look at a Bots and Whisker plot, which uses median instead of mean, that one data value will be just like any other one data value, no matter how big or small it is. So it's another way to be able to look at data and distributions. We know that the median is an average computed by using relative position of the data. If we are told that 81 is the median score on a biology test, we know that after the data have been ordered, 50% of the data fall at or below the median value of 81. The median is an example of a percentile. In fact, it is the 50th percentile. The general definition of the pth percentile follows. For whole numbers p, where 1 is less than or equal to p, which is less than or equal to 99, the pth percentile of a distribution is a value such that p% of the data fall at or below it, and 100 minus p% of the data fall at or above it. In figure 3.3, we see that 60th percentile marked on a histogram. We see that 60% of the data lie below the mark and 50% lie above it. So if you're at the 60th percentile, that means the score is better than 60% of all the other scores. And it's 40% less than all the other scores. So better than 60%, but worse than 40%. So the percentile says where in the group you lie. There are 99 percentiles, and in an ideal situation, the 99 percentiles divide the data into 100 equal parts. However, if the number of data elements is not exactly divisible by 100, the percentiles will not divide the data into equal parts. There are several widely used conventions for finding percentiles. They lead to slightly different values for different situations, but these values are close together. For all conventions, the data are first ranked and ordered from smallest to largest. A natural way to find the pth percentile is to then find a value such that p% of the data fall at or below it. This will not always be possible, so we take the nearest value satisfying the criterion. It is at this point that there is a variety of processes to determine the exact value of the percentile. We will not be very concerned about exact procedures for evaluating percentiles in general. However, quartiles are special percentiles used so frequently that we want to adopt a specific procedure for their computation. Quartiles are those percentiles that divide the data into fourths. The first quartile, Q1, is the 25th percentile. The second quartile, Q2, is the median, and the third quartile, Q3, is the 75th percentile. Again, several conventions are used for computing quartiles, but the convention on the next page utilizes the median and is widely adopted. First, order the data from smallest to largest. Second, find the median. This is the second quartile, so the middle number, which we've talked about being able to find. Number 3, the first quartile, Q1, is then the median of the lower half of the data. That is, it is the median of the data falling below the Q2 position and not including Q2. The third quartile, Q3, is the median of the upper half of the data. That is, it is the median of the data falling above the Q2 position and not including Q2. In short, all we do to find the quartiles is find the three medians. The median, or second quartile, is a popular measure of the center utilizing relative position. A useful measure of the data spread utilizing relative position is the interquartile range. It is simply the difference between the third and first quartiles, Q3 minus Q1. The interquartile range tells us the spread of the middle half of the data. Now let's look at an example to see how to compute all of these quantities. In a hurry? On the run? Hungry as well? How about an ice cream bar as a snack? Ice cream bars are popular among all age groups. Consumer Reports did a study of ice cream bars. 27 bars with taste ratings of at least fair were listed, and cost per bar was included in the report. Just how much does an ice cream bar cost? The data, expressed in dollars, appear in Table 3.4. By the way, these are very cheap prices, and I would buy any bar for this much. As you can see, the cost varies quite a bit, partially because the bars are not of uniform size. So part A, find the quartiles. We first order the data from smallest to largest. Table 3.5 shows the data in order. Next, we find the median. Since the number of data values is 27, that means there's 27 numbers, there are an odd number of data, and the median is simply the center, or 14th value. The value is shown boxed in Table 3.5. That is 0.5. So the median, Q2, is 0.5. There are 13 values below the median position, and Q1 is the median of these values. It is the middle or seventh value and is shaded in Table 3.5. As you can see, it's 0.33. There are also 13 values above the median position. The median of these is the seventh value from the right end. The value is also shaded on Table 3.5, and it's 1.00. B, find the interquartile range. So Q3 minus Q1. Q3 was 1, Q1 was 0.33. 1 minus 0.33 is 0.67. This means that the middle half of the data has a cost spread of 67 cents. So what that means is that the middle data has a range of 67 cents. So most of the data goes from 33 cents to $1. Exactly 50% of the data does. Bots and Whisker plots. The quartiles together with the low and high data values give us a very useful 5-number summary of the data and their spread. The 5-number summary are the following 5 numbers. Lowest value, also known as the minimum, the first quartile, Q1, median, the third quartile, Q3, and the highest value, also known as the maximum. We will use these 5 numbers to create a graphic sketch of the data called a Bots and Whisker plot. Bots and Whisker plots provide another useful technique from exploratory data analysis for describing data. How to make a Bots and Whisker plot. Draw a vertical scale to include the lowest and highest data values. It doesn't have to be vertical. I've often seen them horizontal, and whether it's vertical or horizontal, it's completely fine. Second, to the right of the scale, draw a box from Q1 to Q3. Include a solid line through the box at the median level. Draw vertical lines called whiskers from Q1 to the lowest value and from Q3 to the highest value. So, we've got the highest value right at the top, that is the end of the whisker. Q3 starts the top of the box. The median is in the middle of the box. Doesn't have to be exactly middle. As you can see, the top half of the box is much smaller than the bottom half. This shows skewness. Then Q1 ends the box, and then the lowest value is at the bottom. That's the minimum. The next example demonstrates the process of making a Bots and Whisker plot. Make a Bots and Whisker plot showing the calories in vanilla flavored ice cream bars. Use the plot to make observations about the distribution of calories. We ordered the data and found the values of the median Q1 and Q3. From this previous work, we have the following 5-number summary. The low value is 111, Q1 is 182, the median is 221.5, Q3 is 319, and the high value is 439. Notice the median is a decimal because we had to find the average of 209 and 234 because we had an even amount of numbers. We select an appropriate vertical scale and make the plot. So we went from 111 to 439, so we went with 100 to 450. The Bots and Whisker plot for calories in the vanilla flavored ice cream bars. So, again, high value is 439, that's the top. Q3 was 319, starts the box. The median was 221.5 is the middle. 182 is Q1, and then the bottom, 111. A quick glance at the Bots and Whisker plot reveals the following. The box tells us where the middle half of the data lies, so we can see that half of the ice cream bars have between 182 and 319 calories, with an interquartile range of 137 calories, which is 319 minus 182. The median is slightly closer to the lower part of the box. This means that the lower calorie counts are more concentrated. The calorie counts above the median are more spread out, indicating that the distribution is slightly skewed toward the higher values. So if you see this and you think of skewness that we've talked about a lot, where it's clumped, where there's really skinny amount of data, that's where there's more data. So there's not a lot of space between 182 and 221.5. That means there are a lot of data values in this spot. So the skinnier it is, the more data there is. And you can even see the bottom whisker is much shorter than the top whisker. That means there's more data on this bottom whisker. So that means there's a lot of data on the bottom, or towards the left if we had it horizontal. So that means there's a lot less data up top. So that means it's skewed towards the higher values. Or if we had it horizontally, it would be skewed to the right. Now time for the sponge. The number of chips found in 20 different bags of Lay's are listed below. First thing I want you to do is find the 5-number summary. So, as I explained in the video, find all 5 numbers of the 5-number summary. Part B, use that 5-number summary to construct a box plot of the data. Please make sure to label your graph appropriately. Part C, how would you describe the distribution of the scores? Are they symmetric? Are they skewed left, skewed right, or you can say skewed towards higher values, skewed towards lower values? If your box plot is vertical or horizontal, doesn't matter, up to you. And then D, calculate the interquartile range. All right, that's it for the lesson. Once again, please make sure to take notes, take a picture, attempt sponge, rate yourself, have a good night, and not specifically in that order. Have a good night.